Good afternoon, everyone. I'm just going to move these because I like to pace around a little bit. My name is Andrew Almeida. I am the managing partner for Rise and Shine Partners. We are a blockchain infrastructure manager. My background is in the traditional finance space. I'm a CFA charter holder and a certified financial planner. I have spent a career managing multi-asset class portfolios. Today, we are going to talk about blockchain, not crypto, right? And I have a question for everyone, and that is, what in the world has happened to rational economic man? Everyone remember that old guy where we're supposed to make decisions rationally? And where do we sit today? We sit in a world where we have this crypto side represented by Crypto Bro over here that will grab onto almost any acronym that they can find to raise money and shill it down your throat, right? It's created a terrible reputation for the industry. And then on the other side, I think we only have rational economic woman left. She is a traditional finance person, right? We have, on the TradFi side, been, more or less afraid to adopt the crypto industry, right? Crypto. Now, the question is, how do we bring these worlds together? How do we get trust enough from the crypto side or the blockchain side, right, so that we get adoption in traditional finance? Because my opinion is that this gets its growth, right? We get real adoption when we have real utility, and financial institutions are adopting blockchain, right, as a technology, right? So we need to start over. We need to start from the beginning to build that trust. And we got to go back to what Satoshi did. What was the breakthrough technologically? Okay, yes, he created Bitcoin, this permissionless, trusted payment network, right? That's global. Anyone can participate. And you can trust that when I send you a Bitcoin, if I send you one Bitcoin, everyone in the network knows I've sent you that one Bitcoin. We all agree on that in the network. And he did that by changing the way that we think, the way we come to agreement, okay? Classical consensus requires that every node on a system communicates with every other node, okay? So in classical computing and classical consensus models, it works something like the US Senate, right? If we want to remove centralization, the vote counter who tells us what the result of a vote is, how would we come to agreement as a body of 100 people? Right? So let's say I send Anthony $100, okay? We know that $100 has been sent between us, but how does the community know, right? That's where we're going to get to. In the US Senate example, if we wanted to know like what the vote of a vote count was, every individual voter would have to vote, and then they would have to count every other vote, all 99 votes. So I vote, I count all 99 votes. You vote, you count all 99 votes. So that we all get to consensus at the end, that we all know what the vote count is. Anthony's president, okay? That doesn't scale up because every person has to count every vote. So at 200 people, I don't have to count 99 votes, I have to count 199 votes. So that we can all agree, right? So that if you come in and say, no, I won the vote, I'm president. No, every single one of us has counted the vote. We all know that you're lying. We can't trust you in that system. Okay, so that result wouldn't count. Satoshi, through cryptography and encryption, not only secured the messages, like your messages are encrypted in WhatsApp, but by changing the protocol, the way we come to that agreement, change the way we come to agreement. So it works like this, very simply. Think of like your encrypted WhatsApp message. Now, again, I send an encrypted message to me and Anthony. It's $100. Everyone now, the other 99 nodes on the system, let's say, they start all this computing power to crack what's inside that message. Okay? Someone cracks the code first. They find out I gave Anthony $100. They broadcast it to the network. Everyone tests that answer, proof of work, they test the math, and they start agreeing that that is the answer. And by competing to do that, an incentive reward is necessary. That's called a Bitcoin, to keep us mining and reaching consensus and confirming transactions. Right? He changed the way we come to agreement. So that in that example, let me go back. Actually, yeah. So this is what we're talking about, right? The Nakamoto Consensus Protocol. Change the way we come to agreement. We can agree on the status of the network because all the nodes agree on what's in the network. It can be trusted by the participants because of the protocol, the way the protocol works. As every mine competes to win the reward, to process the next transaction, if I broadcast an answer that I try to say, what's your name, sir? Harry tries to say that I sent him the $100, as everyone else is proving the work, they would say, no, you didn't. Okay? That's a breakthrough. And that's the fundamental thing that everyone's missing or has forgotten. The breakthrough in the technology is the way we agree on information, on data. Okay? And Bitcoin can only confirm that Bitcoins are sent between people. But we can use this technology, this confirmation of information in a decentralized way for all data. Okay? So let's talk about the fundamental components of a blockchain system. You have the consensus protocol, where Satoshi made his innovation, right? How we come to agreement. The virtual machine processes the data and executes the contracts. And then the blockchain, which is the single source truth. Now that we've confirmed and agree on the data, we can store the data and all agree that what's on the ledger is agreed by all of us. Okay? Satoshi made an innovation in the first part. Okay? The consensus protocol. That's where the technological innovation happened. Where did Vitalik make an innovation? On the second part. On the virtual machine. Okay? And we'll get into Ethereum in a later slide. But where are we today? We're in a world that worlds are colliding, right? Worlds are colliding. Assets are moving on-chain, real-world assets, and digital assets are listing on exchanges. So why do we have this coming together, right? From the one side, we have companies coming to the blockchain to start tokenizing assets and put them on chain, right? It's better compute, more efficiency, cutting costs in terms of automation of smart contracts, and more trust, right, if you're building on a trusted network. And we're seeing real-world assets, treasuries. The city of Quincy, right here, put a municipal bond on chain, was issued on the JP Morgan Onyx blockchain. Diamonds, right? Our partners Oasis Pro have a diamond fund that has been tokenized. And the tokenization of assets are moving onto better systems, more trusted systems. But at the same time, we need liquidity, right? There's no liquidity to bring into these marketplaces. So the crypto assets are beginning to move on chain to get liquidity through traditional structures. So where is the world going? We need to support the right protocols, get enough liquidity to the right protocols that are trusted so we can move real-world assets on-chain. Okay? And if you don't think real-world assets are coming on-chain, and that's where the innovation in blockchain is coming, just take it from the CEO of Franklin Templeton, right? Said she believes all mutual funds and ETFs will be moving on-chain. And we'll get to some of the work that's been done behind that. But that leaves the kind of the question to where we started off. Can blockchains support the financial system? Right, like we have the scalability issue, right? The blockchain trilemma, one of them is scalability. Can blockchains actually support the traditional financial system? And I've just pulled out a couple of pieces of data where, as a sample, and looking at people who are involved. JP Morgan has been a leader with the Onyx blockchain, issuing assets like the City of Quincy municipal bond. And that blockchain settles $2 billion a day. JPM also has the JPM coin, their own effective, stable coin, settles about $1 billion a day. But JP Morgan as a company moves about $10 trillion a day. So we're nowhere near ready from a scalable point in terms of like the infrastructure is there. The infrastructure is still being built. We could look at NFTs, we could look at all these other kind of things, but we need infrastructure to get real-world assets on chain. There's another quote, something that's commonly looked at. TPS is this metric everyone wants to consider, and this is why people in the TradFi world are like, what are we talking about? Why are we going to move on chain? We get more TPS out of the NASDAQ than anything, right? Why are we doing this? So we may need multiple blockchains to support the financial system. But I pose another question. Are we asking the right question about why we're using blockchains? So we need to start asking the right questions. Up to now, it's, why are we building on a particular chain? When we think about it, people go for its speed, its liquidity. Are we going for its consensus? Are we going for the programming language? Are we going because of its low gas fees? Right? Why are we selecting a particular chain? And in my experience, having worked in the industry only on the blockchain side for three and a half years now, everyone goes to Ethereum either for the liquidity. They think that's where liquidity is. You're going to get way more liquidity going to the traditional financial system, right, than you are going to get from Ethereum. And then for the programming languages. I'll ask another question. What are we actually scaling? What are we trying to scale? Are we scaling a public database? Are we, Ethereum? Are we scaling the public store of value, Bitcoin? Are we scaling cross-border payment systems? Are we scaling our stablecoin share on market? Maybe we want to get more USD on market. We want to scale that. But what needs to kind of move forward for blockchains to scale? And I would say that, if we go back to what Satoshi, right, going back to the beginning, what Satoshi broke through for us is we need to scale trust. And how do we scale trust, right? Because with trusted agreement of the state of the network, if we could agree on the data or information that's in our network, not a Bitcoin, but maybe the quality of a good, the authentication of a good, right? The use cases get very far and wide to start using shared ledgers. We can use them on the supply chain. We can use them for an exchange. Payment networks has been an obvious one. To remove cheating out of gaming. One of the most interesting projects, I think, in one of the simplest ones, if you look at what the International Chess Federation has done to remove cheating from online gaming in chess, it's because they're authenticating each chess movement in a decentralized manner. And if someone wants to cheat and inject code into that system, they're going to find that out that person was the cheater. Right? So there's the applications of using trust as opposed to just What we're doing on Ethereum, all these transactions offline on some layer 2 or some other centralized service, and then we're just using the blockchain for decentralized storage. Those are two different things. Satoshi's breakthrough was agreement. It's the consensus. It's the protocol that we need to scale. It's trust, right? And I think that mostly happens on permissioned blockchains. There's a lot of advantages to using permissioned blockchains. I don't think public blockchains will go away. But when we think about how the financial system, counterparties, different banks, different regulatory environments are going to use blockchain for its trust, you need to be able to permission who uses that environment, who validates the transactions, where those validators sit, that they're in the jurisdictions abiding by data privacy laws. And then, some people have said, is the permissioned still true to the decentralized nature of blockchain and what Bitcoin found? Because I think the average person has thought that decentralization just means that it's totally permissionless and everyone can use it across the globe. Yeah, that's Bitcoin. But if we're going to scale the concept of trust, we need a system and a protocol that it has done this at the protocol level, and you can trust to scale blockchains. Okay? And before we get to where I believe that goes, we're at this point we're just getting to the cusp of adoption. We're just starting to see real-world assets move on chain. We're just getting this token. This is just the beginning of the financial system, right? The JP Morgans, the Wisdom Trees, the Wellingtons, the Fidelities, stepping into this world. They're just getting started. So if they're just getting started now, the last 10 years there hasn't been adoption. That's because we spent the last 10 years trying to scale a system that doesn't really work that well for mass adoption and the traditional financial system, right? What are we doing on Ethereum where, we have these layer 2s, we have layer 3s, they had to move from proof of work to proof of stake. But Ethereum uses the Casper protocol, which has to communicate like the US Senate example, right? So we had to create these layer 2s to scale on top of it. But what's happening when a layer 2 comes in and prints that this data packet of information to the the Ethereum chain? In many instances, if we go back to the example before with the $100 payment and us all confirming it by the proof of work sharing, on the Ethereum side, and someone tried to come in and say oh, I had $100 and we realized it wasn't you. We confirm his transaction, we put it on the blockchain. What a layer 2 is essentially doing is saying, many of them, is someone's walking in that door and they're saying, I have 100 transactions, put them on the blockchain, that they've done centrally on their network or on some centralized server, and then the confirmation or the consensus that's happening on Ethereum is that we then agree that packet came in and that transaction happened, and then we're agreeing on that. But the 100 transactions inside weren't confirmed. They weren't in a decentralized manner necessarily. They may have been, right? There may have been another blockchain that moved it to the Ethereum blockchain that did this that was confirmed decentralized originally, but that may not be the case, right? You have central points of failure on scaling the Ethereum system. Okay, let's move a little bit more forward. How do you scale trust? We got to build more trusted networks. We have to build on trusted protocols. And if you think permissioned isn't true to the nature of this, I would argue that permissioned and the democratization, the decentralization of finance is when you have a choice. When you have a choice to be public or permissioned. I mean, what is public but permissioning to everybody? So you want to be able to permission your validators, you want to be able to protect the data, you want to be able to own your data, or at least have the choice of doing that. Right? So how is that different from other networks? Bitcoin's permissionless, you have mining pools. Ethereum's permissionless, they use some sharding architecture to get transactions confirmed. Solana's permissionless also, but it's leader-based. They put the transactions into clusters. So when I say permissionless, that means just anyone can validate transactions. And everyone will have that finalized stored data. But many applications and users may not want that, right? And then I used an example like Hedera, which is permissioned, but the validators are like, is a council of validators. So you don't get to choose the validators. They're just using institutional validators like Google and Amazon. But you might as well, it's effectively the data sitting with them like it is on Web 2. We did a little bit of this. And we'll get to where I believe is one of the best solutions in the industry right now, which is what our fund supports, is the Avalanche blockchain. On Avalanche, you have a choice. You have a choice to be permissioned or public. And the Avalanche consensus protocol has made innovation at the consensus level to reach finality and come to agreement. That's being done at the consensus level, not by building more centralized processing on top of the decentralized network. So the Avalanche consensus protocol, and Avalanche itself, it effectively works as a blockchain as a service. You go to Avalanche to launch your own blockchains, right? So that if me, Anthony, and Harry want to share data and information amongst ourselves, and I run a validator and they each run validators, well, we can agree on all the data that's shared there, or the settlement of our trades, transactions, whatever we want to do on that network, because we have permission to who's come in, and we trust the protocol to come to agreement for us. To agree on the state of the network, on the state of the data that's been transmissioned. On Avalanche, you can use any virtual machine, right? Meaning you can use the Ethereum virtual machine. You can use the Solana virtual machine to process your transactions. So if you like the speed of Solana and how they process transactions, you can use that virtual machine on the Avalanche consensus protocol. But if you want to build a decentralized app where all the users trust what's on that app, because the information has been verified in a decentralized way, that gets done by the protocol. And ultimately, on Avalanche, you have a system of multi-blockchains, right? A multi-chain system where you can choose, again, have the choice to connect to other blockchains. So what does the future look like? We've gone from Bitcoin, Ethereum, Avalanche. I'm telling you, is one of the protocols I believe will succeed in scaling the permissioned world for permission chains. Well, let's take a live look at some of the things that have been done. Right, this is an image from JP Morgan's Project Guardian, where JP Morgan connected their internal Onyx blockchain to WisdomTree for the automation of personalized portfolios and the settlements of trades with JP Morgan of the assets in those portfolios. Now, how did they connect the JP Morgan chain to WisdomTree? So that they can both trust the data that gets confirmed on that network, so that they can use blockchain automation and trust the trading, the settlement, and both sides have that in real time. Think about what this changes. For everyone who's worked in finance and sent an Excel file back and forth to an auditor or their admin, and they're spending hours and hours reconciling information. Entire departments of reconciliation will be wiped out because we can trust the data has been verified by protocol, and we trust who's on the network with us. We've permissioned who comes in. So, our partners, Oasis Pro, are here. They participated in this as well for the tokenization aspect. All right, tokenizing the asset which lives on the chain. But the chains that were of choice that were trusted for the project was the Provenance blockchain on one end and the Avalanche blockchain on another. But we envision a world where this connection happens in thousands of instances between banks. Right? The adoption is just going to start. So where does that leave us? It leaves us with a new type of investing, a new type of infrastructure investing, where we invest in trusted protocols, we operate that infrastructure, and then, similar to alternative asset funds that you may have seen that do real estate or lease rail cars or any other type of infrastructure, here the infrastructure that you want is the trusted protocol to build your application on. And I think the proper way to do that, we looked at these worlds colliding earlier, is in a fund structure. Go to where help the traditional finance world allocate the way they know how. In a traditional fund structure, in trusted protocols that are paying you your rewards and not keeping them from you, right? Whereas if you're going to buy the ETF, if you buy the ETF for Ethereum, anyone could just go on Coinbase, buy the ETF, buy Ethereum. They could go buy the Ethereum ETF, get no yield, right? Or in some instances, if you want to use a protocol that doesn't have the approval of a 40 Act product, you would need to use the appropriate structure. And that's how you get liquidity to the appropriate protocols. As opposed to just building the next restaking token on-chain or the next DeFi lending platform to lock more TVL. We need to build out the validator infrastructure for the networks that are going to be used to scale the financial system. And it is of our opinion that the Avalanche consensus protocol is one of the few trusted protocols that has the ability to do that. Have a few seconds, minutes for questions. Questions?
So I've also done a lot of research. I mentioned this to you before about Avalanche, and there's an incredible amount of science, incredible amount of grants, a lot of innovation happening. I'm wondering, to your opinion, do you think there's a reason it's not catching on more, specifically with institutions? Like you said, like Provenance was built for institutions, so the fact that JP Morgan picked them and Avalanche says a lot. So I don't know, do you have any insight?
So the Avalanche consensus protocol launched in 2021. It's been 3 years of people getting educated on the differences in the protocols. And on the team, the Avalanche, the Avalanche team getting out and educating people on what the protocol does. If you're looking at adoption, I would argue that, yeah, we're getting it. California State just put DMV records on the Avalanche blockchain. You see JP Morgan using it in their testing. Deloitte built an application for FEMA, for the federal government, on the Avalanche blockchain. What are some more, Julie? But when you see institutions adoption because they're using for decentralized agreement for why we're here, for what Satoshi broke through, right? You're using the Avalanche blockchain for that agreement. Any others?
I have a follow-up question really quick. I'm so sorry to everyone else. But I love the term you just used earlier, blockchain as a service. I've never heard that before. Do you think that's going to be a trend we're going to continue to see in the industry?
Absolutely.
Yeah.
Absolutely. And one of the holdups in scaling for Avalanche and for all blockchains is the capital required, right? Avalanche is a proof of stake mechanism. That's the mechanism. It's not the protocol. Okay? The mechanism is that you have to put up that collateral to run a node to operate the protocol. So if I want to build an application on Avalanche and we want to share the nodes so we can confirm information in a decentralized way, well, we need to start putting up more nodes, right? Or get people to service those nodes. And the reality of the industry adoption is that you have a shortage of IT people, so that when startups are building, they don't actually have the IT know-how and infrastructure to run them. So as a fund, we're stepping in to do that for them, and also put up the capital, so that they don't have to put up as their network expands. It's 2,000 Avalanche per validator. If it's $25 an Avalanche, that's $50,000 every validator you put up. So we're coming in to kind of fill those gaps to help with scalability as an infrastructure fund.